Hello, everyone. Welcome back. My name is Mr. Cobalt, and we are going to start to get into the atomic theory. But before we get into the atomic theory, we have to talk about the observations that led up to the atomic theory. And so, before we get started, I'm going to talk a bit about the laws that led to the formulation of the atomic theory as we know it today, or at least when it started. Um, so there are three main laws that support or have led to the acceptance of the atomic theory. The first law is the law of conservation of mass. The second law is the law of definite proportions, and the third law is the law of multiple proportions. And I'll be dealing with all three laws in separate um, videos. So in today's video, we're going to go over the law of conservation of mass. But I want to say a few things to remind ourselves what a law is and what a theory is. So I mentioned the atomic theory. We need to remember that a theory is a general explanation of what we see in the world around us, right? So we observe things and we want to know why it is that that occurs, or why is it we observe things behaving in certain ways. And so we come up with theories or even hypotheses to explain those sorts of things. So a theory is an explanation of these general observations we see. Now, a law is different. A law is a statement of those observations. It's a general statement of what we actually observe. It's not a theory. We're not trying to explain anything in a law. We're just stating what is observed generally. Okay, so the law of conservation of mass is something we observe all around the world. Um, so the atomic theory is a theory that explains that observation, that attempts to explain that observation. And it's the three laws that I mentioned earlier: the law of conservation of mass, the law of multiple proportions, and the law of definite proportions. The atomic theory seeks to explain those laws, those general statements of our observations. Okay, so that's a key distinction. And so I just wanted to talk about that in this video. So the first law that we are going to talk about is the law of conservation of mass. And this was formulated in the late 1800s, or I'm not 18th century, late 1700s. In 1789, Antoine Lavoisier, a French scientist, but he was also a tax collector. He was responsible for taking taxes of anything that went in and out of Paris at the time. This is around the time of the French Revolution, and Antoine Lavoisier ended up losing his head because he was a tax collector, and we all know how people feel about taxes. But in addition to that, he was a very meticulous scientist. And so he would do many, many experiments, innumerable experiments, with the help of his wife. And he would meticulously measure everything out. He was so careful to measure everything. And in his experiments, he found that the masses of the reactants would always come out to the mass of the product that was formed every time. So, and so that's why we call it the law of conservation of mass, because this is something that's observed over and over and over again wherever you are. Okay, so an example of this would be if I had 22.99 grams of solid sodium metal, and I react that with 79.99 grams of chlorine gas, then when I collect the salt that's formed, I should get 102.98 grams of salt. And this is the kind of experiment that would be done, and these are the measurements that would be done, and it would be found that this side, if you add the masses of the reactants together, they would equal the mass of the product every time. So then the question is, well, how does this support, or how does atomic theory lend itself to explain this? Well, this fits, or it coincides, or is consistent with the idea of matter being made up of individual particles, indestructible particles. So these particles do not get destroyed, but they are rearranged. So the theory kind of fits with that, because if that is true, then you would definitely expect that if you have the same atoms on one side of the equation, you have the exact same atoms on the other side of the equation. So you don't lose the atoms, and the atoms have a particular mass, so you're not losing any mass. So you would expect the masses to be the same. So the only thing going on is a rearrangement of these indestructible atoms. And so this is consistent. This theory is consistent with what we observe. So that shows support. So again, in the next videos, I will be talking about the law of multiple proportions and the law of the law of conservation mass, the law of multiple proportions, and the law of I'm forgetting the name. I just said it. Direct proportions. So I hope this video was helpful. If you liked it, share this video with others. Subscribe to the channel so you can get more videos. Make a comment in the comment section, and make sure you click the bell so you get notifications. And thanks for joining me, and I'll see you guys next time.